this next section, we're going to look at how scientists are able to determine how old some things are. So, first of all, they have an estimation that the Earth itself is at least 4 billion years, somewhere between 4 billion and 5 billion years. And one method that they use to establish this is called radioactive dating. Now, the first concept that you need to understand radioactive dating, is the concept of isotopes. And we talked about this a little bit earlier in the year. It's a concept related to chemistry. So we know that all elements have a certain number of protons, or their atomic number. And so their atomic mass is a combination of protons and neutrons. The number of protons cannot change. If you have a different number of protons, then that changes the element. But you can change the number of neutrons. So for example, here we have hydrogen, because all of these substances have one proton, making them hydrogen. However, they have different numbers of neutrons. The first one has no neutrons, then the middle one has one, and then the last one has two neutrons. So again, the number of protons determines the element itself. The number of neutrons can change. Now the mass number, like I said, is a combination of protons and neutrons. So for protium, the mass number would be 1. For deuterium, the mass number would be 2. And tritium, the mass number would be 3. So because we have these different numbers of neutrons, these are called isotopes. Same number of protons, different numbers of neutrons. Many times, these certain isotopes of an element are unstable. And when they're unstable, they tend to go through what is called radioactive decay, which means that they give off particles, they might give off energy, but that decaying is called radioactive decay. Because elements do this, or these isotopes do this, we can have an idea of how long it takes them to do this. And this is what's called half-life. So half-life is the amount of time it takes for 1/2 of a certain isotope sample to decay. So if we look at this chart here, let's say we started out with 1,000 units of a certain isotope. In a specific amount of time, maybe 1,000 years, half of that isotope will have decayed. So now we're down to 500 units. In another 1,000 years, another half will have decayed. So we've gone down from 500 to 50. In another 1,000 years, it's going to decay in half again, so 250 to 125. And every 1,000 years, half of the sample that you have will decay. And this is the concept of half-life. So if we know we started out with 1,000 units and we're down to 250, we can calculate how many times would that have split in half, how many half-lives have gone by. And this helps us determine the age of a lot of very, very old artifacts. The most commonly known isotope when associating with half-lives in radiocarbon dating is carbon-14. Carbon is something that is in all living substances. Most of the carbon is in the form of carbon-12, but there's also carbon-14. And so they use this carbon-14 to do radioactive dating. They're going to look at the ratio of carbon-12 to carbon-14 because carbon-12, the amount doesn't change once an organism dies, but carbon-14 begins to decay. So they can compare these two amounts to determine how old the substance is. So the half-life of carbon-14 is 5,730 years. So they can determine how much is gone and how much time would have elapsed since that organism would have passed away. Now the drawback of this is in terms of 4 to 5 billion years of the Earth, this is only good for organisms that are 75,000 years old or less. So relatively young organisms. Some other isotopes that might be used, potassium and uranium. So they can use these for older substances, not necessarily living things, obviously. So potassium 40 has a half-life of 1.3 billion years. Uranium 238 has a half-life of 4.5 billion years. So when we're dating living organisms that may be older than we can use carbon-14, we have to come up with some other ways to date these organisms. And one of these ways is using rock layers or strata. And so if you look at this picture, you can see it looks like there are lines in this rock formation. And so over time, the older substances are going to be at the bottom, and the newer rocks are going to be layered on top. So the newer material is at the top and the older at the bottom. So if we can date things maybe down a few layers with carbon-14, organisms that are older, if we can find non-living things and date them with other isotopes, if they're in that same layer, then they're going to be about the same age. So that's another method using rock layers or strata to date things that might be too old to use carbon-14.